In this section, we're going to be taking a look at the stack interface. So in the past, we used the one that was built into Java, but this time we're actually going to define our own interface that we can implement. And we're actually going to end up implementing this thing twice. So in this chapter, kind of in the next two sections, we'll implement this thing in terms of arrays. And then in the next chapter, we're going to implement it again in terms of a list. So here we're back in BlueJ. On my right-hand side, I have the source code for the interface. And I could compile this right now, but it's not actually going to do anything. I can't run this. This is just an interface file. So in this file, I'm not defining a class, I'm defining an interface, right? So the interface is essentially a list of methods, right? A list of behaviors, list of functionality that exist. So here we have interface stack ADT. So anything that wants to be a stack, right? A stack abstract data type would have to implement this interface, which means you would have to provide functionality for this list of methods that's in this file, right? So if I want to implement a new stack ADT, I have to implement things like push, pop, peek, and so on, right? That's the idea of an interface, right? And then if we have some sort of outside program like postfix evaluator, that program would use a stack in terms of this ADT, right? In terms of stack ADT, you would have a stack ADT variable instead of a stack variable, which was the Java default one. And then on the other side, I would have some other classes that I've written that implement this interface and provide this specific functionality. Some people call this also like a contract, right? Anything that wants to call itself a stack has to provide this functionality to the outside world. So looking up top, we're going to see again these arrows, right? So this is generics, right? So we're saying that, oh, this stack interface involves the generic T, right? So we want to have stacks that can store doubles, they can store strings, they can store integers. And in order to do that, what we're going to do is we're going to have a generic type, right? We're going to have this T type that's not actually defined yet. When we actually go to use the stack in our program, for example, postfix evaluator, that's when we'll go in and say, oh, this particular stack, this is going to be containing integers. Until then, this interface is just going to say, oh, it's just generic, right? It's some T type, right? It's going to be what's stored in this stack. So this is our generic, just to make this whole thing, more flexible. So let's look down and see what exactly is in here. One thing you may notice is that here we're using Javadoc syntax. So we have our multi-line comment, right, with the stars, and then we start off by giving a general description of the method. So here we have adds the specified element to the top of the stack. And then over here, right, we have our little annotated comment, right, which says, oh, the parameter called element, the meaning of that parameter is that it's the element to be pushed onto the stack. So this is a basic description, right, of the functionality for the push method. If I was someone using this interface, this is the text that tells me how to use this thing, right, what it does. On the flip side, if I'm someone who wants to build a stack, this text is telling me the same thing. It's telling me this is the functionality you need to provide in order to be a stack, right? Your push method better do this, right? It can't go do something completely random. It has to follow this definition, right? This specification that's kind of in the comments here in the interface. And we have this for all the methods inside the stack. So the first one here was push, right? Which we talked about. That was the method or the function, the operation that would put something on top. And then we also have, next one's going to be pop. So pop was kind of the one on the flip side. Which was, oh, let's take an element off of the top, right? Hopefully there's something there, otherwise we might need to think about doing an exception. But this was the one for remove it from the top. And again, you can see that in the text description. Removes and returns the top element from the stack. If I'm using a stack, this is how I expect it to work. If I'm implementing a stack, this is what I better provide. Going down here, I have the rest of them. I have peek, which is basically a method that looks on the top. And then tells me what's there without removing anything, without changing the contents of the stack. It just looks at the top. Then we have isEmpty, which is something that's going to return true if the stack doesn't have any elements in it. This is a Boolean return type now. These other ones, these past two were T, right? Our pop and our peek were T because we didn't know what type would be stored in there, right? That's kind of going to be our generic type. And actually that was over in push as well, right? Push's argument, right? The parameter that was going to that method, the thing called element, right, the type on that was T, because again, that was our generic type that we don't know yet until someone actually goes to use this stack inside of their program. So they have the three generics here, and then the rest of our methods. So isEmpty, size, right, size is returning an integer, and that's just going to give us the number of elements in the stack. And then the last one here, and maybe it's a little bit redundant, is toString. All methods are going to have some sort of temporary toString that's available to them that Java puts in automatically. But here what this is saying is, you need to have a toString, and then here, that toString is supposed to return a string representation of this stack, right? So it's just telling us, what should that toString return, right? What do I expect to get back from it? So as a whole, this is just our list of methods that a stack must implement together with comments that define how they should behave. So in the next couple of sections, what we're going to look at is actually building our own stack class that uses an array to implement this interface, right? So we're going to build our very own stack collection.